In this lab, we investigate both the reflection and refraction of light through experimental methods. The first part of the experiment focuses on verifying the law of reflection by measuring the incident and reflected angles using different types of mirrors. The second part examines how light behaves when passing through an acrylic prism, allowing us to determine its index of refraction. By comparing our experimental results with theoretical values, we can evaluate the accuracy of our measurements and identify possible sources of error. In this experiment, we used an acrylic prism and a ray box to observe how light behaves during reflection and refraction. Plane, concave, and convex mirrors were used to compare how different surfaces reflect light. A protractor was used to measure angles accurately, while auxiliary pages helped guide the setup and data collection. Finally, pencil and paper were used to trace light paths and record observations throughout the experiment. In the reflection portion of the experiment, the ray box was placed on a flat surface and adjusted to shine light toward a mirror. The mirror was positioned on paper, and its outline was traced while a normal line was drawn at the point where the light ray would strike. The incident ray was directed at the mirror at different angles, and both the incoming and reflected rays were traced on the paper. Using a protractor, the angles of incidence and reflection were measured from the normal line. This process was repeated for multiple angles to ensure accuracy, and then repeated again using concave and convex mirrors. All measurements were recorded for comparison. In the refraction portion of the experiment, the acrylic prism was placed on a sheet of paper, and light from the ray box was directed into the prism at a chosen angle. The path of the incident ray was marked as it approached the prism, along with the refracted ray as it passed through and exited. A normal line was drawn at the point where the light entered the prism, and the angles of incidence and refraction were measured using a protractor. These measurements were recorded and repeated for a different angle to improve accuracy. Snell's law was then used to calculate the index of refraction for each trial, and the results were averaged to determine the experimental refractive index of the acrylic prism. The results of this experiment showed that the law of reflection was supported across all types of mirrors. The plane mirror produced the most accurate results, with no difference between the incident and reflected angles. The concave and convex mirrors showed small deviations, which were likely caused by minor measurement or alignment errors. For refraction, the results showed a noticeable difference from the accepted value. This deviation was likely due to factors such as inaccuracies in measuring angles, errors in tracing the light rays, and slight misalignment of the prism during the experiment. The experiment successfully demonstrated the law of reflection, with very accurate results for plane mirrors. However, the refraction portion showed a larger percent error of about 30%, indicating some limitations in measurement precision. These errors were likely caused by small misalignments and difficulties in accurately measuring angles. Improving alignment and measurement techniques would likely produce more accurate results for determining the index of refraction. When comparing the percent errors, the reflection measurements had very small error, around 0% for the plane mirror and about 1 to 3% for the curved mirrors. In contrast, the percent error for the refractive index was much larger, around 30%, showing that it was significantly more affected by measurement issues. A large portion of this error was likely caused by measurement problems, such as incorrect placement of the ray box, difficulty in aligning the prism, and small inaccuracies when measuring angles. These factors made the refraction results less precise compared to the reflection measurements.